Okay, so all week we've been talking about triangle congruence, and we've talked about the 5 shortcuts we can use to prove two triangles are congruent, such as SSS, SAS, ASA, AAS, and HL. And today we're going to conclude this section talking again about triangle congruence, but we're going to talk about this 5-letter abbreviation called CPCTC. And CPCTC stands for corresponding parts of congruent triangles are congruent. Sorry, I ran out of room. Congruent. Okay. So CPCTC, we will say that a lot, and it's hard to say fast, but CPCTC stands for corresponding parts of congruent triangles are congruent. And I'm going to say this over and over and over and over and over again until we can get this correct. What CPCTC stands for, what it really means rather, is we've already said if I give you two triangles like this, and I give you something that looks like this, we can say that these triangles are congruent to each other because of this shortcut SSS. So cool. So now we know that these two triangles are congruent by SSS. Now, even though I didn't tell you anything about the angles, because these triangles are congruent, we know that their corresponding angles are going to be congruent. So for example, this angle has to be congruent to this angle because they're in the same spot in both triangles. So they're called corresponding. These angles are corresponding to these angles, so they have to be congruent to each other. And lastly, this angle has to be congruent to this angle over here because those are in the same spot. And because these triangles are absolutely congruent by SSS, those two angles would have to be congruent. That's called CPCTC. Because these angles are in corresponding parts of the triangle. They're in matching parts of the triangle. And we already know that these triangles are congruent. These parts have to be congruent to each other. So by CPCTC, the corresponding angles, corresponding angles are congruent. Okay, so we're going to use CPCTC to prove parts of triangles are congruent to each other today. So for example, number 1, it says A and B are on the edges of a ravine. What is side length of AB? Or how long is AB? Okay, so let's look at this. And this kind of looks a little confusing. But the first question you want to ask yourself is whenever I'm asking you about parts, I want you to first think about proving the triangles are congruent. Then I want you to use CPCTC. That's the process that you're going to use. So the first question you ask yourself is, are the triangles congruent? Whoops. If they are, sweet. Whoops, sorry. Okay. So are they congruent? Sorry. Oh, man. Okay, I get it this time. I'll get it. Okay, are these triangles congruent? So let's look at this picture. Well, we know that this triangle has a side length of 10 miles, and this triangle has a side length of 10 miles. So we have one set of congruent sides. We know this triangle also has a side of 15 miles, and this triangle has a side of 15 miles. Cool. We know two things. We have two sides. Oh my goodness. And then look, we have these vertical angles. Oops. Vertical angles in the middle here. So we have a side angle and a side angle and a side. So these triangles are congruent by SAS. That's the first step. And if I scroll, let's see if it'll let me scroll up just a little bit. Sweet. First step, use SSS, SAS, sweet, SAS. That was the first thing we did. We proved that the triangles are congruent. Now that the triangles are congruent, even though I don't have tick marks on AB, I know that AB is going to be absolutely congruent to this side because they're corresponding parts. They're in the same spot. So AB looks like this one in this other triangle. And since those triangles are congruent, they have to be congruent. So that's what CPCTC says. So I know that AB has to be 18 miles because the corresponding parts of these congruent triangles are congruent. All right, so you're going to try to do number 2. Again, I want you to have both steps. Are they congruent? If so, how? And then answer for the length of JK. Now the second thing, and mostly what we're going to be using CPCTC for, are proofs. So yay, I'm going to do one proof with you guys. It says, given, and here's all my given stuff, prove parts are congruent. Not triangles, parts. But the process is going to be the same. First, you're going to use either SSS, SAS, ASA, AAS, or HL to prove triangles are congruent. Then you're going to use CPCTC to prove parts are congruent. To prove the end. Okay, so since we're talking about angles, it says angle XYW is congruent to angle ZYW. I know I'm going to have to be using CPCTC at the end. Okay, so we still start off with our given just like we were used to doing. So given. And let's see, what do they give us? They tell us XY is congruent to YZ. XY is congruent to YZ. Okay, XY is congruent to YZ. All right, and let's see, that's a side length. Sweet. All right, it also tells us, we haven't done one like this yet before, side length YW bisects side length XZ. That's a given. It didn't say that they're congruent, so I don't necessarily know that those are congruent to each other, but let's see what that looks like in our picture. This side length YW bisects this side length XZ. So bisects, that means it's going to cut it into 2 congruent pieces. So that means this piece is going to be congruent to this piece. Okay, so now I know XW has to be congruent to WZ. And that's another side length that is set that are congruent. But what's the reason? Well, I talked about the word bisects up here. So I'm probably going to have to use it down here. Because the word bisect means to cut something into 2 congruent pieces. For number 3, I can say these are congruent because that's the definition of that word. That's the definition of a bisector. Okay. Let's see, I only have 2 things. I know I need 3 things in order to use one of these shortcuts. So, the next one will probably be that YW is congruent to itself by the reflexive POC. And I'm running out of room, so I'm going to carry this on over here, but hopefully you guys have enough room on your paper. Okay, so that's the third side. Now I'm ready to prove that my triangles are congruent, and that's the first thing I told you guys to do. So we're almost done with this proof. So for step 5, I know now that these triangles are congruent, and I know that they're congruent by side, side, side. So now I have to state that those triangles are congruent. And this is where our triangle congruency statements come in hand. Because we said earlier, remember in class, I said I like to read 1 tick mark to 2 tick marks to 3 tick marks. So I'm going to label my triangles YXW, YXW, and then let's see, if I do the same thing for the second triangle, it would be YZW, YZW. And if I wanted to, I could check it by looking and seeing at the angles. So for example, W and W angles, those angles should be congruent to each other. And W and W are in the same spot. Same with Y and Y. Those should be in the same spot because those angles are congruent. And X and Z look like each other. And X and Z are in the middle too. All right, sweet. So most of the time, this is where we would stop our proof. But we're going to go one step farther with CPCTC because I want to prove that this angle XYW is congruent to ZYW. ZYW. So because those are our corresponding parts, I'm going to finish my proof with that. Angle XYW is congruent to ZYW, and that last reason is going to be CPCTC. CPCTC. And for this class, this will always be the last ending for if you see that parts, we're trying to prove parts are congruent versus triangles are congruent. So I know this is tricky. I want you to try to do this proof, but definitely do the reflection. And we will continue with this proof tomorrow in class. Fun fact of the video, did you know a seed can blow across an ocean and sprout on another continent?